Okay, so this is a test for review. There are 14 questions, but I'm going to skip any repeated, questions. So question number one, a magazine provided results from a poll of 1,000 adults who were asked to identify their favorite pie. Among the 1,000 respondents, 13% choose chocolate pie, and then margin of error was given as plus minus 3 percentage points. Given specific sample data, which confidence interval is wider? The 95% confidence interval or the 80% confidence interval? Why is it wider? So as you can see here, 1,000 responded, 13% choose chocolate pie, and then there is a margin of error plus minus 3 percentage. So the we need to find out which one give the wider confidence interval. So whenever you have 95% confidence, the interval should be wider for sure. So it's a 95% confidence interval must be wider than 80% confidence interval in order to be more confident that it captured the true value of the population proportion. So this is the right answer. Okay, so where is the next problem? I don't see it's I don't see this as a answer. Let me go back here and check my answer. Yeah, that's right. Let's go to the next problem. We need to find out the critical value corresponding to the confidence interval 93%. For that, we're going to use TI-83 calculator here. That's what I have available. So for that, go to the second distribution number 3, and then it takes the area to the left. Here it's 93%, so alpha is 7%, alpha over 2 is 3.5%. That alpha over 2 3.5% is to right, and to use this function here we need area under the curve to the left, so which is 100 minus that what is that 3.5%, which is actually 96.5. So in knob of 0.965, remember 0.965 is the area under the curve to the left of this chi-score. Okay, so that is 1.8119. so if you round it to the 2 decimal place, then it would be 1.81. So let's check the answer. That's right. Let's go to the next problem here. Next problem, use the sample data and confidence level given below to complete part A through D. A drug is used to help prevent blood clots in certain patients. In clinical trials, among 4,519 patients treated with the drug, 191 developed the adverse reaction of nausea. Construct a 95% confidence interval for the portion of the adverse reaction. So first of all, we need to find out the population proportion, which is in this case, as you can see here, out of 4,519 patients, 191 developed the adverse reaction. So just divide 191 by 4,519. That gives us population proportion, which is, if you round it to the 3 decimal place, it would be 0.042. So identify the value of the margin of error. So what is the margin of error? How do you find it? There is a formula, so let's check our formula here. Okay, so there is a formula for the margin of error. Here is the formula. Where is that? This one. E equals G square times square root of P hat times Q hat divided by N. So in this case, we already found, where is that? Okay, we have a population proportion, which is 0.402, which is P hat. And now for finding the margin of error, we're going to use this formula. But for that, we need to find out the critical value first, the way we found in previous problem. So let's use our calculator one more time. Go to the second and distribution number 3. and then for here it's a 95%, so it's a 0.97. What is that? It's a 2.5. 1 minus 2.5 is 97.5, so it's a 0.975. So we are looking for the z-score such that the area under the curve to the right is 2.5%, because alpha over 2 is 2.5%, but area to the left is 97.5%. that's why it gives us the z-score. So we need that z-score here, and then we need to multiply this by square root of sample proportion times 1 minus sample proportion divided by n. So I'm going to multiply this by sample proportion, which is second square root. Inside that it's a 0.042 times 1 minus 0.042, because q hat means it's a 1 minus p hat. Okay, so double parenthesis and then divided by what is that, divided by n. N is, in our case, it's a what is the n? It's a 4519. 4519. I guess I typed it under this radical sign. Otherwise, okay, it looks like I did not type it under the radical sign, so I'm going to do it one more time. Look at here, the z-score is 1.9596, so I'm going to use z-score 1.96 and to calculate this p hat times q hat. So p hat is 0.042. What is that? 0.042 times q hat is 1 minus 0.042 and enter, divided by n. N is 4519, and take the square root of this number, second this and second, and this one takes the answer. Take the square root of that number, times it by the z-score, which is 1.96, and that gives us the margin of error, which is 0.0058. If you round it to the 3 decimal place, it's 0.006. Now construct the confidence interval after this margin of error. We know the confidence interval is, if you check here, it's a sample proportion minus margin of error, sample proportion plus margin of error. So we have the margin of error 0.006 and sample proportion 0.042. So we are going to subtract sample proportion margin of error from the sample proportion, and that gives us the lower limit for this confidence interval, which is 0.036, and for the upper limit we are going to add this sample proportion with the margin of error, which is 0.036. Sorry, it's not 0.036, it's 0.006. If you add this to a number, it gives us 0.048. Okay, so that's the confidence interval. So among this, one has 95% confidence interval that the interval from the lower bound to the upper bound actually does contain the true value of the population proportion. That's the meaning of confidence interval. If I check the answer, that is right. So let's go to the next. Okay, so this is a question where we need to find the confidence interval. It's similar to the previous problem, so I'm just going to go over this very quickly. A random sample of 860 births in a state included 426 boys. Now, by using this information, we need to construct a 95% confidence interval, estimating the proportion of the boys in all births. So first of all, for that, like we did in previous problem, in this case alpha is 5%, which is opposite to the that percentage we have given. So alpha over 2 is 2.5%, so 1 minus alpha over 2 is 0.975, and now using this value we can calculate the z-score using our TI calculator, TI-8384 calculator. And by using this G score in this formula, because it calculates the margin of error, and plugging the the proportion, population proportion, uh, divide 426 by 860, and then q hat is 1 minus p hat, which is this value. By using this formula, this margin of error is 0.0334, and now this is the confidence interval, so just plug the value of p cap minus e and p cap plus e. That gives us this value, but in this problem they are asking us to round to the 3 decimal places, so the answer is 0.462 to 0.529. Now according to this second statement, it is believed that among all birds the proportion of boy is 0.509. So this 0.509 is inside this confidence interval, so there is not strong evidence against this belief. Okay, so that is our answer for this problem. Okay, in a science fair project, Emily conducted an experiment in which she tested professional touch therapists to see if they could sense her energy field. She flipped a coin to select either her right hand or her left hand, and then she asked the therapist to identify the selected hand by placing their hand just under Emily's hand without seeing it and without touching it. Among 349 trials, the touch therapists were correct 164 times. Complete the parts A through D. So, given that Emily used the coin toss to select either her right hand or left hand, what proportion of the correct response would be expected? Since she used coin, so there is a 50-50% chance, so the expectation should be zero point 0.5, which is 50%. Okay, using Emily's sample result, what is the best point estimate of therapist success? So best point estimation means it's uh, as you can see here, out of 349 trials, 164 correct, so it's 164 divided by 349. So based on this sample result, the proportion is 0.469, so it should be 0.470 if you want to round it to the 3 decimal place. And we can find out that confidence interval the way we found in previous two problems, very same idea. You need to find out the you know this confidence interval by finding what is this called, it's a margin of error, E, by using this formula. So I'm going to repeat the very same thing here. Margin of error, this is the same idea like this. So margin of error E can be found by using this formula, P hat Q hat divided by N. So we know P hat is, it's given 0.47, and then Q hat, it's 1 minus 0.47, which is 0.53, and N in this case, it's a sample size, which is 349, 49, and the critical value G alpha over 2, it is, first of all, alpha is it's given, it's what is that, it's 95% confidence interval, so alpha should be 5%, and then alpha over 2 0.05, alpha over 2, it means 2.5%, which is 0.025. So when we try to find the critical value, we are going to use the same idea, second this number 3.975, and that gives us 1.95. If you round it to the 3 decimal places, it would be 1.9596, so 1.96. So now using this formula we can calculate this value. So I'm going to do that. First of all, multiply 0.47 times this p hat times q hat, which is 0.53, and divided by n, which is 349, and then take the square root of that. Second is square root of answer, which is this one, times it by the z-score, which is 1.96, and that is our margin of error, which is 0. If you round it to the 3 decimal places, it's a 0.052. After finding the margin of error, we can find the confidence interval by subtracting this value from p hat, which is in this case it's a 0.47. 0.47 minus this margin of error is 0.052, that is 0.418. And then the upper margin confidence interval can be found by adding this 0.47 with what is that margin of error, which is 0.052, and that is 0.522. What do the results suggest about the ability of touch therapists to select the correct hand by sensing energy field? So as you can see here, the confidence interval is 95%, such that population proportion would be in between these two numbers. And as you can see that 0.5, which is 50% chance, is also in between those two numbers. So since the confidence interval is not entirely below 0.5, so since the upper confidence limit is above 0.5, since the confidence interval is not entirely above 0.5, okay, since the confidence interval is not entirely above 0.5, there does not appear to be sufficient evidence that touch therapist can select the correct hand by sensing energy field. So it's not entirely above 0.5, so there is no enough sufficient evidence that touch therapist can select the correct hand by sensing energy field. Okay, so that's the right answer. Let's go to next problem. Okay, some states now allow online gambling. As a marketing manager for a casino, you need to determine the percentage of adults in those states who gamble online. How many adults must you survey in order to be 99% confident that your estimate is in error by no more than 5% points? So to find out the sample size, we're going to use this formula here. There is a formula for finding the sample size. Assume that nothing is known, so that means the second formula we're going to use, we need to find out the g-score and then margin of error, and we can find out the sample size. So let's look at here, what is the g-score in this case for 99% confidence. So the g-score for that would be second variance number 3, that's 99%, so it would be 0.995, because alpha is 1%, so alpha over 2 is 0.005. So to the left side of this g-score there is a 0.995% of area, so the g-score is 2.57. so we found the g-score. Where is that? We found the g-score. We have to square the g-score, and then we also need to find margin of error. So here the margin of error is no more than 5%, so it's a 0.005. so using that fact, if you divide this by 0.005, no more than 5%, it's not 5%, so I'm going to delete this. It's a 5% now. So I divide g-score by margin of error as given here in the formula, and I'm going to square it. So squaring of this gives me squaring of z-score and then squaring of e-score, and I'm going to multiply this by 0.25. Remember, this is the very same number I'm going to use when the sample proportion population proportion is known. So I am going to use 2653.95 one more time, but now I'm going to multiply this by 0.25, and then it gives me this number. I'm going to round it to the next number, which is 664. It's a 664. And for the next problem, assume that 70% of all adults gamble online. So using that fact, if you look at here, 70%, so that means if you go back here, p hat, it would be 0.17. So I need this number 2653.958639, so which is the first half of this formula. I mean, I'm talking about this part, which is I'm going to copy that, which is 53.9588639 times the p cap is, it's a 0.17 because it's a 17%, times it by q cap, which is 1 minus 17%, which is eventually 83%. So let me just multiply it by 0.83. That gives me my sample size, which is 375. If you round it to the next whole number, it's a 375. So let's check the answer, and that's right. Okay, this is the data we have given, and for the 95% confidence level, this is the lower limit, this is the upper limit of confidence interval, this is the mean, sample mean, this is the standard deviation for the sample, and this is the sample size. Based on this information, we have 95% confident that limits of 13.05 Mbps and 22.15 Mbps contain the true value of the mean of population. That's the meaning of 95% confidence. Okay, next problem, we need to find out the t value, t alpha over 2. So based on this information here, first of all, if you have a TI-84 calculator, then it's very easy for you to find out. Just go to second and variance, and then go to number 4 if you have TI-84. But I don't have TI-84, so I need to use stat and test, and go to number 8, which gives me TI interval, which helps me to find out the interval, a confidence interval for t distribution. And then I'm going to use a stat for this particular t value. Always use mean 0, and then the standard deviation for the mean is square root of n, and that's how we can find out the t alpha over 2. So which is square root of n means it's a 6, and then the value of n is 36, and confidence level is, it's a 99%, so we can just type it 0.99, and when we hit calculate, it gives us confidence interval, and on this confidence interval the upper value is our t value, which is 2.7238. If you round it to the 2 decimal places, it should be 2.72. That's how we can find out the critical t value. And what is the margin of error? Margin of error can be found by using our formula, which is this one, t value times standard deviation for sample, and divide by square root of n. So here we have t value, which is 2.72. If you round it to the 2 decimal place, it's a 2.72, times it by the standard deviation for the sample standard deviation, which is given, it's a 688.5, and then hit enter, divided by square root of n. Here n is 36, so square root of n is 6, so that is our margin of error, which is 312.12. So 1 decimal place, so it's 312.1. And now using this margin of error, we can find out the confidence interval. As you know, confidence interval means mean minus this margin of error for the lower limit. So the mean is, in this problem it's given 3216.7 minus this margin of error, which is 312.12. So the answer is, the lower limit is 2904.6. If you round it to the one decimal place, 2904.6. For the upper limit, we take this sample mean, which is 3216.7 plus margin of error, which is 312.12, and that gives us upper limit of this confidence interval, which is 3528.8. 3528.8. That's the confidence interval. And based on this information, we can say one has 99% confidence that that the interval from the lower bound to the upper bound contains the true value of the population mean weight of newborn girls. So this is the weight of newborn girls. So this is the meaning of 99% confidence. Okay, let's go to next problem. This is a very similar type of problem but different scenario. If you go back to this problem, the way we found this confidence interval, we need to find t-value. We need to find, even without finding t-value, we can find out this confidence interval by using this same formula, same function here, by going test and number 8. We just have to use the stat here, the given stat, and the mean for this problem is a data set includes 103 body temperature of healthy adult humans having a mean 98.9, and that's the mean, and the standard deviation is 0.67, that's given, and the number of sample size is 103, and then our confidence level is 99%, so it's a 0.99. It's already given. So calculate. When we hit calculate, it gives us confidence interval. This is the lower limit, this is the upper limit. So 98.727. If you round it to the 3 decimal place, 98.727. And for the upper limit, it's a 99.073. And if what does this suggest about the use of 98.6 Fahrenheit as the mean body temperature? You can see that this 98.6 is lower than even the lower limit. So this suggests that the mean body temperature is lower than 98.6 degree Fahrenheit. No, this suggests that the mean body temperature is higher than 98.6. So as you can see here, there is a 99% confidence that mean body temperature should be higher than this one. So check your answer. That's the problem. And for this problem, you can also use table given here, but I use the calculator. This is this very similar question like previous one, so I'm going to skip it. So let's go to the next problem. You have data here and you want to find out this confidence interval for 95%. So we can use very same command here by going here stat test, and by going to number 8, which is where is that? Number 8 is ti interval. Instead of stats, this time we have the data, so we can use data. Okay, so for the data, we can store our data, and then we can say, hey, find out the confidence interval for this data. So for the data, we can go here, where is that? Stat, edit, and then we can store our data here, L1. So as you can see here, this is the archaeologists have studied sizes of Egyptian skulls in an attempt to determine whether breeding occurred between different cultures. Listed below are width in millimeter of skulls from 150 AD. Construct a 95% confidence interval estimate of the mean skull width. So if you copy this data, if you can see here, I can 1 2 3 4 5 6 7 8 data, 1 2 3 4 5 6 7 8. So even I don't need this Excel here. I can just copy enter this data here, which is 127.7, enter 137.8, enter 126.2. So I'm just storing this data in the list 1, 132.3, and I'm going to use this list 1 while calculating the confidence interval 142.7, and then 134.8 and 139.1. So finally 129.4. Let me just double check this data here. 1 2 3 4 5 6 7 8, 129.4, 139.1, 134.8, 142.7, 132.3, 126.2, 137.8, 127.7. Okay, that's all. So that's the data. Now let's go to the stat and test and go to number 8. So which is use the data from the list 1, frequency 1, and then confidence level is 0.95, and just hit the calculate here, and it's going to calculate the confidence interval for this data. And here, as you can see, that average mean is 133.75, and this is the confidence interval lower limit, which is, if you round it to the 2 decimal place, it's a 128.85, and then upper limit it's 138.65, 138.65 if you round it to the 2 decimal place. So that's how we can calculate confidence interval. Okay, we need to find out the sample size. Find the sample size needed to estimate the mean age. So remember, this is a mean estimation. So for the sample size, we can go here and then use the formula we have given for the sample size from our mean estimation section. This is the formula for the sample size. In this formula, as you can see here, you need critical value, you need standard deviation, and you need margin of error. So let's look at here. Find the sample size needed to estimate the mean age of movie patrons such that it can be said with 95% confidence that the sample mean is within 2 years of population mean. So look at here, this 2 years is a margin of error. Assume that the standard deviation is 19.3 years based on a previous report. Could the sample be obtained from one movie at one theater? Okay, now so there is a 95% confidence interval confidence. So for that 95% confidence, we can find out the G-score, and for the G-score, go to this variance second, and then number 3, INV of 95%. So alpha is 5%, alpha over 2 is 2.5%. So we're going to find out the INV for 97.5%, and that is the G-score for this alpha. And then we have the G-score, and we also need standard deviation. So standard deviation is, let's times it by standard deviation is 19.3, and then we have to divide it by the margin of error, which is 2. So if we square that, that's where we are going to find out the sample size, and you just have to square this answer, which is 357.726. The required sample size is 357.772. So whenever you have decimal sample size, round it to the next whole number, it's a 358. Now the question is, assume that this is the standard deviation based on previous report. Could the sample be obtained from one movie at one theater? Okay, so the answer is the sample should not be obtained from one movie at one theater, because that sample could be easily biased. Instead, a cluster sample of broader population should be obtained. That's the first option. The sample should not be obtained from one movie at one theater because the sample could easily be biased. Instead, a stratified sample of a broader population should be obtained. The sample should be obtained from one movie at one theater because that sample is representative of the population. The sample should not be obtained from one movie at one theater because the sample could be easily biased. Instead, a simple random sample of a broader population should be obtained. So I'm going with this. So that's our answer. Because one, sample size of one, that's not good. So we need to choose simple random sample. Okay. Okay, let's find out which of the following is not a property of a student t distribution. A student t distribution has a mean t equals 0. That's right. The standard deviation of the student t distribution is 1. That's wrong. So this is not the part of the standard t distribution. Okay, so we are done for this one.